Hi, in this video we are going to see how to build a neural networks classification model with the H2O platform in R running on Google Colab. So the first step would be to install the H2O package on Google Colab. So we can use this command install.packages and H2O in quotes. Once installed, we can load the H2O package with the library command and initialize an H2O cluster with h2o.init. With the h2o.clusterinfo, we can print the information about the H2O cluster. Next, we can start working with the data. For this example, I will be working with the cardio_cvds.csv file, which contains information about the occurrence of cardiovascular disease for a number of patients. So first, we will upload that file into the current Google Colab session, so we can use this folder icon on the left. And then with this upload to session storage button, we can upload the file. So we search for the file in our computer and then select it, open to the file to be uploaded. Okay, so that is uploaded. Next, we will do some preprocessing of that data. We will be working with functions from the tidyverse for that preprocessing. Basically, we are going to convert we're going to transform the variables. The continuous variables such as age and weight will be standardized such that their units become standard deviations and they are centered around the mean of each variable. And for the other variables, gender, cholesterol, smoke, alcohol, active, and cardio, we are going to convert them to factor data type. The dependent variable here is cardio. So 0 means no occurrence of cardiovascular disease and 1 means occurrence of cardiovascular disease. So this will be the variable that we will be trying to predict with the classification model. After doing that, we convert the cardio data frame to an H2O frame, and that will be needed for the later steps. Okay, so that's done. Next step would be to split the data into a training set and a test set. We can use the H2O.splitFrame function such that 70% of the data goes into the training set and the remaining 30% into the test set. Next, we are going to create a vector here with the name of the dependent variable cardio and another vector of character strings with the names of the predictors such as age, weight, alcohol, and others. Okay, so we can fit a neural network classification model in H2O using this function h2o.deeplearning. In this first example, we will be using most of the default settings, and we will be editing some of them. The first inputs will be the vector with the predictors, the vector with the name of the dependent variable, the H2O frame with the training data, and if we want, we can include an ID for the model. In the default settings for this function, the hidden argument defines the number of hidden layers, and by default, the number of hidden layers is 2. And there are 200 units or neurons in the first hidden layer and 200 neurons in the second hidden layer. But we are going to change that. We're going to make a smaller neural networks model. So I'm going to say, okay, let's create a model with 2 hidden layers, 20 neurons in the first hidden layer and 20 neurons in the second hidden layer. If we want to add more hidden layers, then we could do here, let's say 10 and 10 or something like that for neural networks with 4 hidden layers. For this example, we will only use 2 hidden layers. By default, the number of epochs is 10, and this doesn't run cross-validation, so the number of false here will be 0. We are going to edit this standardized argument. We already standardized the continuous variable, so we don't want to do that again. So we will set this standardized argument to false. The default value is true. And if we want, we can set a random number generator seed for this running of the code. So let's run that code. Okay, so this finishes quite quickly. If we want, we can see the information about the model that we fitted. this neural network classification model. So as we see here, the number of units is 20 and 20, so these are the two hidden layers. By default, it uses a rectifier activation function, 0% for the dropout rate and 0 for the L1 and L2 regularization parameters. So this is the first model that was fitted, and then we will see some information about the metrics reported on the full training set, and we see the confusion metrics and other metrics. This is the maximum metrics at the respective thresholds. Okay, if we want, we could print the history of the scores values. So here we will see the errors, for example, the training classification error in the first epoch or in the 10 epoch. So if we do more epochs, then we will see here a larger table. Also, we could print or plot the score history. Here the training classification error is decreasing, but we are only running 10 epochs, so this is just a small try that we are doing here. Okay, instead of working with the default settings, we could try this with more extensive search of optimal values for the hyperparameters. For example, we could try other activation functions such as max out or tan h. Also, we could try other values for the L1 regularization parameters or L2 regularization parameters. So if we want to try this, for example, then we would create a list with these values that we want for the activation function or for the L1 regularization parameter or the L2 regularization parameter. And we also define a search criteria, same as a list. We define the strategy. Here this will be a random search instead of a Cartesian systematic search, and we can define some constraints. For example, here we don't want to run for longer than 10 minutes. Okay, so these are the parameters for hyperparameter tuning. We can print those parameters, so we see here the values for the hyperparameters that we'll be trying, and the number of models will be 108, but we will be not running all of them because we will be running this random search. Okay, so to run that random search of parameters, we will be using the H2O.grid function. Before doing that, we will split the H_train set into a training set and a validation set for this running of this function. So we create these splits with this function H2O.splitFrame, and then we run that search of the optimal values of the hyperparameters with this function. First, we define what algorithm we are going to run. Here we will be doing neural networks, and then we define the vector with the predictors, the name of the dependent variable. If we want, we can set a model ID. In this case, I am not going to do that. I'm going to let R save this with an automatically created ID, and then here we enter the set that contains the training data and the set that contains the validation data. Again, we will be running this with only 20 units in the first hidden layer and 20 units in the second unit layers. So in these models, we will only have 2 hidden layers. But we are going to increase the number of epochs to 100, and then we will be running this through cross-validation. Here, tenfold cross-validation. We will not standardize the continuous variables. We set a random number generator seed, and we enter these parameters that we defined previously for hyperparameter tuning. Okay, so we would run this. I already ran this code, so I'm not going to run it again, but we are going to see the results. So if we print this object, then we will get the details about this grid. So we see that we try to tune 3 hyperparameters, the activation function and the L1 and L2 regularization parameters. The total number of models that were run was 26 out of the 108. And then we see the the results here. We see each of the models, for example this first model with these parameters, and then we will see the log loss metric, and same for the other parameters. Once that is done, we can extract, or first we would sort the data in this table according to some metric, for example accuracy. So we take that grid of models and we sort them by accuracy in decreasing order, so we will get the models with the highest accuracy at the top of the table. So let's do that and take a look at the table. So here we see the table, and if we scroll up to the top of the table, we see that this model with these parameters was the best model. So the optimal values for the activation function was rectifier, and the optimal values for the L1 and L2 regularization parameters will be 0.001 for both of them. And the accuracy for this model was 0.68, so 68% accuracy. Once those models have been sorted, then we extract the best model, in this case the first model, which is the model at the top of the table, which showed the highest accuracy. So we define what is the ID for the best model, and then we get that model with this function h2o.getModel. And as the last step, we could evaluate the performance of that best model on the test set that we had created previously. So we use this function h2o.performance, and we enter the name of the model, which was this one, best_DL, and then we evaluate on this set, which is the test set. So let's run that, and then we take a look at the metrics, and then we will see, for example, the area under the ROC curve, which was 0.67, and then for the optimal values of the metrics, then we see, for example, here the confusion metrics for the F1 optimal threshold, and then we have a set of metrics, and for each of the maximum values we got the respective values for the respective thresholds. So that would be how we would run a neural networks model with this H2O framework. Hope you liked this video. Thanks for watching. Don't forget to subscribe. See you in the next video.